All right, so I'm here today with Manny Poliniappan. Is that close? I'm really bad at last names. As well as Sankeet Songwi.
Yes.
Close enough. Both from Manhattan Associates. Sankeet is a principal in the operations research side of Manhattan, and Manny is an architect in the professional services side. And they both work predominantly on the transportation management systems. So what I want to do, just talk about TMSs, both the business side and some of the decision support, the OR side. So first question, you guys have been involved with implementing and designing and building TMSs for 10 plus years. What have you seen change from the business side over that time frame, Manny?
In the last 10, 15 years, right, to be quite honest, the transportation network of our customers, they have gotten quite complex. It used to be very simple back old in the days. If they are dealing with something like inbound, they were using traditional modes of transportation like truckload, less than truckload, but that's pretty much it, right? Outbound, if they own a fleet, they have milk runs, static routes,
right.
That you're familiar with. They use static routes to haul it. They assign drivers and they are done with it. But if I look at the landscape of transportation today, it's quite it has changed quite dramatically. They want the supply chain systems or transportation systems of today's world to be agile. They want it quite user friendly. They don't want to do any system or data maintenance within the tool, but at the same time they want to do everything much more efficiently in a cost-effective manner.
So shippers have gotten lazier and more demanding.
That's correct. Yep, exactly. And when I started the implementation, they were okay with like setting up the system, managing lanes, managing customers. Now they pretty much want everything autonomous, and they want hands-off operation with just exception reporting.
Okay.
And also, in the last few years, everybody has gone mobile. Things are moving towards cloud. They want mobile, and with the offshoot of Uber-like services in the freight market, they expect TMS to catch up with those evolving technologies, and that's what has changed in the last few years.
So what about the decision support side, the models and the modeling behind it? How has that changed over the last 10 years?
So as Manny mentioned, right, initially it was a truckload was an LTL problem.
Right.
Whether you go truckload, whether you want to fill loads into a route problem, where the routing decision is made between a TL and an LTL. Things have changed because now with the introduction of last mile delivery, you also have parcel to be considered. So a mode selection, intermodal. You also have not just truckload, not just LTL. You have parcel. You have train. And
you have fleet too, private fleet as well.
Fleet as well, and those have drastically changed. The complexity has changed, and as Manny mentioned, right, with Uber-like services that are coming up, a lot of focus has been on a sourcing problem rather than a routing problem, because routing is there; it's always been there as a fleet optimization problem. But now the focus is more on a network design, where do we source this DC? Where do we source this store from? How do we make sure that all the customer demands are observed in the best possible way, and which DC is the DC to be sourced from?
Seems like one of the things that's happened over the last 15 to 20 years is it used to be, as you said before, very segmented. Inbound didn't talk to outbound at a lot of DCs. The modes didn't talk to each other, international and domestic. So I assume that's been merging. Have you seen that from most companies?
Yep. They all want a single holistic system. The siloed, I think everybody has realized, I think we are beyond the tipping point now, everybody has realized that the siloed approach doesn't work. They understand that there are synergies to be leveraged if they work together. One classic example that I always give my client, right, to make them understand that the siloed approach doesn't work is the backhauls integration with your outbound processes. You can say the same thing with Dre integration on the inbound. So there is a lot of redundant processes if they operate siloed. So it's not just the technology that has some catching up to do. They have to honestly, they should be open to changing their business.
Yeah, because that's a big process change. Because usually those people hated each other and they competed. Yeah.
Exactly. So now I think they all realize that there are a lot of benefits not just from a technology standpoint, even from a process and business operation
Right.
standpoint, they're all working together and make sure that whatever redundancies and inefficiencies that they have within their network, it could be solved if they work together.
See, the funny thing is, teaching classes for operations, for like an optimization model, bigger is always better theoretically because you have more options and potential. But it's there's a double-edged sword though, because the problem gets bigger, it's harder to solve. So how has that affected bringing things together? Are you able in the models to capture all the potential benefits and synergies from that integration?
Well, you point out correctly. The model becomes difficult. The amount of data that's required becomes more. The model becomes more complex to solve.
Right.
It's not just. I remember in the past we had probably thousands to probably at the max 1 million different variables in a solve. But now that has exploded wrong. But at the same time, the technology has also improved over the past years.
Right.
So you could see there are these big data. You could see a lot of growth in infrastructure for big data,
Right.
distribution data management,
Right.
where you basically could solve it in a different nodes and essentially come up with an optimal solution. So
Yeah, but some of these problems, especially any kind of vehicle routing,
Right.
is inherently NP hard, right? It's exceptionally hard. As you get bigger, it just goes
Right.
incredibly hard, which raises the question, sometimes back in the good old days when we were selling the same a version of TMS at 4 different parts of the same company instead of one big one, you could isolate their problem and you could solve it optimally individually. Now it wouldn't be optimally globally, but the question is, do you still see optimization leading the way, or are you finding more heuristics getting engaged?
both. So initially the focus was only on optimization.
You can't have both. They can't both.
Because we are still in transition.
Okay,
so,
sure.
so in the transition period, we still have customers actually using. But our focus in the past couple of years have been on heuristics method, not just pure solver-based optimization where we develop a model, we pass it to a solver and a black box who comes back with a solution. But it's more of a heuristic-based solution where we know we can solve the problem and we can achieve it in a much faster, efficient, and a better way.
So when you're going to customers and designing a solution for them, do you have to explain the difference between a heuristic, simulation, and optimization? And
Absolutely,
how do you do that? Because I struggle with doing that.
Go ahead.
So we make sure, so basically when we do an implementation for an optimization, the customers usually aren't that very tech savvy to understand between a heuristic problem but an optimization. But we explain them from a point of view of a cost of ownership.
Okay.
Because with any external solver or with any external system integration comes an extra piece of complexity and an extra piece of cost that is associated with it.
Right.
And so with heuristics, what our approach is to basically reduce the cost of ownership to our end customers.
That's it. So it's a cost of ownership
Yep.
is the primary driver, not speed of solution.
There are some markets,
Right.
if I have to relate this to what we do, right? We initially built everything, using the external, approach. We used to work with Cplex, to get our solutions.
So Cplex is a generic solver,
Yes.
right? It's owned by IBM.
IBM.
It's still owned by IBM, but but slowly we realized that that's an additional cost to our customers.
Sure.
It slows down the performance, and as you know, we are kind of in a mission critical application where day to day, once we get the orders, in a few hours we have to give the routing solution for the warehouse to load. Right? You can't stop warehouse pick pack ship operations just because TMS hasn't solved for the load. So and also there are customers with like high dense network, like the pharmaceutical, pharmaceutical distributors, Papa John's Pizza. You can take anybody, right? They all have a high dense network. When you try to solve when you try to solve the optimization using an external model, I think in a high dense environment, I think it got quite complex for us.
Right.
So that's when we started to focus more on the heuristics,
Right.
and then we built all these high density route planning type
sense.
software within our network. So it's mostly cost of ownership, performance, right? How quick of a
Sure.
performance that you need. I think those are some of the decisions, because we have honestly both the flavors right now. We are trying to integrate both these engines into one engine, but depending on the needs of the customer, we have the option to use Cplex versus we can use our own
Makes
HDR.
sense.
Yeah.
Makes sense. So when you look at a TMS, I think you guys break it down into three big phases: there's strategy, planning, and execution. Can you just walk me through, Manny, just the quick steps for that? Because every company's a little bit different,
Yep.
but they kind of do the same thing. So planning,
Strategy.
planning, execution.
Yeah, strategy is what, back in the days when I was new to TMS, my boss always used to say, like, strategy is where, organizations can define their transportation policies, right? You want to have a goal in terms of, this is how I want to run my business, in this case, transportation operations, and you come up with a plan, you come up with a model, how you can manage your transportation operations on a day-to-day basis, right? So strategy, this is where the modeler comes into place. Right. Doing studies like where do I want to place my new DC, where do I if I'm integrating a bunch of new customers into my existing transportation network, am I going to have capacity demand?
And so what's the time frame that the strategy piece goes for? Is that
it's ongoing, actually?
3 months to longer, or it's not a real time?
Actually, there is a strategy team that always is looking out for new studies,
Okay,
right? But a
okay.
typical engagement, is anywhere between, like, let's say 4 weeks to 8 weeks study. But they're going to keep doing this because they're going to have business needs where they want to run different studies at different points in time.
Right, so the studies, but the decisions they make, like someone's not going to create a new DC
That's correct.
this week.
Yep.
So it's for longer term plans, because the impact is huge there, but the cost might be huge.
Yeah, but
go ahead.
Yeah, but something like a integration of new customers into my network, that's an ongoing study.
Absolutely.
Yep.
So then what happens in the planning stage?
So in the planning phase, this is the day-to-day operations, right? I have my rates, I have my capacities from procurement.
Okay.
You have your network strategies or policies from the modeler. Then planning is the day-to-day operations. So basically, you want to come up with realistic route plans. You have to integrate the route plans efficiently with your warehouse. You want to be able to schedule your inbound appointments. You want to be able to manage things within your yard. All of that is like the strategy around managing your day-to-day
Right.
operations from a planning standpoint is what I would classify under the planning piece.
Okay.
And
Then the execution?
then the execution. So under the execution, it's more of like communicating with your carriers,
Okay.
collaborating with your suppliers, collaborating with your carriers, making sure that you're getting real-time visibility. Everybody wants to have real-time shipment visibility, right, where my things are, and then doing the freight audit payment, right?
Okay.
Once I haul the load, making sure that you're paying what the rates are contracted and you're not paying over, and if they want to get total cost of ownership, right, or total cost to serve is, doing the ABC costing,
Right.
where I apportion my freight cost to my item level data so that I know exactly what it costs from a trans standpoint, right? All of that is the execution piece.
Okay, so of these three pieces, which one, do they all get implemented at the same time? Or
Nope.
which one do you see getting implemented first?
So it'll always
Which do
start
you, I
with-
imagine it differs, but what's most common? What do you typically see?
I get involved in the planning stage a lot.
Yeah, because is it also fair to say that there's more optimization in the strategy than in the planning,
Yep.
than in the execution?
Yep.
Right.
Exactly.
We
And
always
so-
start with where the customer is going to get the most bang for the buck.
Okay.
Right? So usually in the pre-project planning phases, we work with the customer to understand their real pain points,
Okay.
right? Where they see a lot of value, because obviously you can't tackle everything at the same go. You gotta phase it out, right? Because these systems are sometimes quite complex, when it comes to implementation. So we work with the customer to understand where they're gonna get the most benefit, and then we try to come up with a realistic plan.
Okay.
As I said, the strategy piece is it's actually we have so many different models that have been in an area of focus or the research side for the past couple of years, where from a strategy perspective we have done a what if scenarios simulation, which includes simulation, and that's been the focus, to be honest, from a TMS perspective for the last couple of years, where things are changing so fast that we need a stronger optimization, a stronger way to represent what that strategy should be like, and simulating that effectively to make a more effective decision right up front. So I get a lot of, I get involved during the strategy phase, but
Sure.
also during the planning phase, where you have to do a day-to-day optimization, which is a fleet routing optimization. You do a lot more a bin packing a problem, career selection, mode selection, and so on and so forth.
So when we look at an implementation, I know back in the late 90s, early 2000s, the thing that took the most time was connecting to the carriers. Has that changed? Has that gotten better? Or is it still the months process, one by one carrier using EDI? How has that evolved?
We are not quite there yet. As you know,
As an industry, not just as a company, I mean as an industry.
As an industry, we are still, believe it or not, we are still using the traditional means of communication or connecting the carriers with the shippers. You have the EDI front, even though a lot of TMS systems have the ability to integrate over the web, but honestly, most of the national truckload carriers and LTL carriers, they don't even care about like logging into a web portal, right? They want integration through the traditional forms of EDI. It has gotten quite complex, to the point that, connecting and doing the same thing over and over and again for every implementation, connecting shippers to carriers, it's quite inefficient. I think everybody knows that. Even we, when I do an on-premise installation, I do the same EDI work to connect the same carrier with every single shipper.
And that's because the EDI is the perfect standard because you can have so many to pick from.
That's correct.
And everyone's unique. Every shipper does something else in column 32.
Exactly.
Yeah, that's the challenge.
Yep. But in the last 3-4 years, at least we have seen some technology providers. These are like third-party integrators that enable that technology. Quite honestly, we could also do it. It's there in our roadmap to do it. But these third-party integrators, they onboard carriers through into their systems and technologies, and then basically all we have to do is software systems like Manhattan. We just have to connect to those providers, and then you are connecting a single shipper with a large carrier base. I think the industry is slowly evolving there. It's not there quite yet because we get requests all the time. Hey, even if I go to SaaS, do I get access to all of the carriers that you have in your SaaS model? The answer is no, right? We still have to.
When you say SaaS, what do you mean?
Software as a service. It's
so
our
SaaS.
Cloud.
SaaS.
Okay.
It's our cloud.
So you call it cloud?
Yeah.
When a company that I used to work for that was acquired by Manhattan, we had a cloud-based system, but it was called ASP at the time, Application Service Provider, and it was not seen positively necessarily by the industry. How has that changed? Because now everything is cloud. I mean, most things. So if you look at your implementations, have you seen a resistance to having cloud implementations, or are shippers wanting them? How has that evolved over the last couple of years?
So I know that there has been a lot of interest, just because the technology has been improved so much, like for Amazon or for that matter, Google, that everyone is moving towards cloud, or at least have heard about the advantages of having a cloud. And there are some significant advantages of having a single tenant or a multi-tenant cloud. What we've seen is there is a lot of interest in the small tier 2, tier 3 companies moving towards SaaS. Although there is some resistance from a tier 1 because they still have a lot of infrastructure and an internal IT system that can handle software implementations and any IT related infrastructure problems. So there is a gradual move, but it is most towards tier 2 and tier 3.
Do you think it's more economic, so they don't have to buy, they only have to pay by the SIP essentially?
Right.
Okay.
Yeah, the model at least that we are seeing, right? If it's a large tier 1 shipper, their transportation networks are quite complex.
Right.
They don't care about spending the money on the hardware and infrastructure and all of the related services. And quite honestly, they want a highly customized solution for themselves, right? So those are the shippers, that they still want to do on-prem. They may have some of these infrastructure and hardware things on their own cloud, not necessarily the clouds that we offer, but it's an on-prem installation, right, for those types of customers. Tier 2 and tier 3, those are customers, typically they don't have a large transportation span, 10-15 million a year.
Yes.
If you throw them an implementation cost of a couple of million, they're just going to be like...
So does cloud technology, does that speed up implementation? Or is
Much
it a
faster,
function
much
that it's,
faster.
what part of it speeds up? The carrier connectivity?
The carrier connectivity, installation of the hardware, installation of the software, and the upgrade cycles. Actually, it's quite faster because we upgrade every year on a set date. Everybody gets upgraded at the same time.
So you do it. So it's not individual.
It's not individual.
So if I'm a company and we're all separate companies, are we all in the same instance? Or are we separate instances?
You have some flexibility.
Yeah, there's a flexibility. If it is a single, if it is a multi-tenant, then even then there is a procedure where we go in a monthly basis where you go live with, or you upgrade it with one customer. And
so
then
we
with the other tenant.
offer multi-tenant hosted and then single-tenant hosted. If you're in a multi-tenant hosted environment, then when we do an upgrade, everybody gets upgraded there.
Makes sense.
But if you're single-tenent, then you get your own.
Now, this usually means there's less room for customization. Right, and so that's the trade-off.
The going-in approach for SaaS implementations is 0 mods, right? We don't want to do any extensions to the software because it will complicate the upgrade path, right? So the going-in position is almost no mods. But if we see some value and we think that if it's just a product gap that we haven't tackled, but we see a lot of customers wanting that functionality, then the approach is we might do it in base and everybody gets it.
Yeah, sure. You manage that pipeline of new features and all that stuff. Makes sense.
And the interesting thing is that's why we see a lot of tier 2 and tier 3 companies having an interest, just because they are not sure whether which TMS to go, whether this solution will really help them, and whether we are paying enough in terms of usage. So that way, SaaS is the best way to onboard them. So they pay for what they use, and they have an idea of what they can expect. So in the future, if they expand and if they want an on-premise,
do you see that? People going from SaaS, the cloud-based, to an on-premise?
We haven't, but that's a potential.
Do you see it the other way? Do you see some people saying on-premise and saying, you know what, I need to go cloud?
Yeah, we have seen at least a couple of.
I would think so, because
when their networks evolve, when their transportation networks evolve, and they have like highly complex supply chain needs, I think that's when we have seen customers move from SaaS to on-prem. But going from on-prem to SaaS is not that common because usually on-prem is like already a highly customized solution. Off-the-shelf software installation does not cut the needs for them, right? So it's not uncommon, but I wouldn't say it never happens.
Okay, because I know even for your system for SaaS, you have redundancy built in, all those kind of things. Even a big company, that's very expensive to build redundancy in data centers. So it's a trade-off. But for implementation, fastest to slowest, roughly for a TMS that you see out there.
In terms of timelines?
Yes.
SaaS, standard transportation modes, I would say 6 months.
Okay.
On-prem, if they want to install all the modes and they have private fleet, dedicated fleet, they do parcel. Everybody does omni-channel today, that, right? Buy online, ship from store to customers, buy online, ship from EDC to customers, buy online, ship from DC to store for customer pickup with all, that type of network. You're into many years.
Yeah. So it's funny, I was just buying something from a store, and we went there. It's a good store. I won't mention the name. And we wanted to buy a piece of gym equipment. We went in, and they said, oh, we have 2 in transit, 3 in these other stores, but we wanted it installed. They knew where everything was, but we couldn't buy it if it wasn't physically there. And because we wanted to place the order for the one coming in, we had to come back the next day to place it. All this kind of stuff. It's so funny. Everyone had the visibility for information, but it's more than that. It's being able to make decisions and do stuff. And they were stymied. They couldn't make a decision. So we went somewhere else.
It's changing though, right?
It is.
In few years, I bet that with solutions like ours, we are investing quite a lot in omnichannel. Manhattan is like very heavily invested on omnichannel. You're going to be, the day is not too far. You will be able to allocate an in-transit inventory somewhere incoming into your network, and we can, we don't want to miss the opportunity.
The other wrinkle is when it's wrapped with a service, a white glove service of some sort. But there's a lot of other things. So it is. So the interesting thing is transportation. If you go all the way back to like mid-90s, it was very well defined and easy. And I mean, it's only been deregulated in the United States for 20, 30 years. So it took that long to evolve. And now it's getting so integrated into other systems. We talked about the integration into carriers, but also these systems have to integrate backwards into the OMS, the WMS, all those other systems. How hard is that integration?
It's mostly becoming everything is becoming base, and everybody wants to build not just a TMS, they want to build platform solutions, right? So if you look at like our company, we are trying to have a OMS, we are trying to have a TMS of our own,
right?
Everything on the same technology stack, right? A lot of companies claim that they are on they can talk to each other, but I'm sending out a message through an integration broker which is getting absorbed on the other end, right? They send POs 3 different times through 3 different systems, but right, because everybody needs an order. But I think everybody wants to have one item master, one PO.
Right.
So you're going to see a cluster of like supply chain systems and then ERP systems, right?
Right.
So the ERP system is going to release an order to the supply chain system, and all of the supply chain needs are going to be met using the supply chain system, planning the PO, sending the PO. If everything is on the same technology stack, then the integration becomes quite easier. But then there is always going to be integration from a TMS to onboard computer, right? You want to be able to integrate with the PeopleNets of the world, IsoTrax, and so on and so forth. You want to be able to integrate with an ERP for accounts payable, right? We got to be able to pay the carriers, right? We want to be able to allocate the freight cost to different GL codes. Right. So those integrations are always going to be there, where a supply chain system may have to integrate with a ERP system. But within the supply chain, right, you're going to see a lot of platform concept.
Makes sense. You're saying there's very few standalone best of breeds anymore. Used to be a best of breed for each kind of slice of the supply chain. Not so much anymore. They're acquired.
That's correct.
Right.
You've seen from an optimization perspective, I've seen people focusing back to their analytics or a business intelligence system. So it might be a Tableau, or it might be a some other.
That makes sense for visualization and things like that, or going into machine learning. So one of the challenges that we're finding is that the ERP systems keep track of certain data, but the data that you want to do your analysis is very different. So if it's financial, has a dollar on it, it's there. It's there in SAP or Kinexys or Oracle. But if you want to know dwell time, if you want to know some of these other things that aren't part of the payment, it doesn't exist in a lot of these systems. So and those are the things that drive our analysis, right? Yeah. So how do you face that?
So we have been having requests that, like Manny mentioned before, that why don't you integrate our execution systems to our strategy systems? And we do integrate for most part, but as you mentioned, there are certain data points that don't talk to each other, and there are certain data points that basically have to be created or exported from some other data points or some other systems that basically have that system decide. So we have had requests with connecting it to, like I said before, Tableau from the way back, because they do some other kind of visualizations outside of the norm. And then you have certain other systems like you might have some data analytics system with Amazon Web Services that require that information, and you get that data and you solve for a particular problem, and then you basically pass it back to some data visualization tool.
Right. And so Tableau is a visualization tool that's very, very popular from some Stanford professors, if I'm not mistaken. It's pretty widely used. All right, any last points you want to make about TMSs?
I just think from a future trend perspective, we have seen a lot of growth potential in big data analytics, because analytics is my domain, and I would talk from that perspective. And we see that a lot of machine learning algorithms, a lot of predictive analytics, and a lot of price optimization.
I've seen a lot of talk about predictive analytics. I haven't seen too many predictive analytics yet.
But
we're seeing there. We're getting there.
Yeah,
that's the frontier.
That's where we want to get more research out of it, and focus our efforts towards, because you have the platform, you have the ability to solve such bigger problems now, which we weren't doing before.
Fair.
Yeah, from a general, transportation industry standpoint, you're going to see, autonomous vehicles in commercial trucking industry. I think we're going to see it in our lifetime, at least for sure. So, it will increase the speed to service for the customers. We also, everybody talks about visibility. But getting the compliance out of the carriers and making it easier for the carriers to provide the visibility, I think Amazon changed the world, right? You know, we are all used to logging into an Amazon website, and I know exactly where the products are. So
UPS was very helpful for that too.
Yes.
Yeah, right.
Yeah, that's exactly right. So you're going to see a lot more on the visibility with these companies trying to have like real-time visibility to information.
That's an interesting thing. That's a topic for another day. But the influx of GPS position versus EDI, you know, one's I was here at this time, went through this step. Another is latitude, longitude, time, and one provides better information, but the other provides context. And so I don't know too many systems that merge those that well together. But that's a challenge. It's an opportunity, but it's still a challenge.
Yep. And then you're going to see more of cloud, right? Everybody wants to go cloud. Everybody wants to go mobile. Those are some of the key trends, at least we are observing in the general transportation industry.
All right. Well, thank you, Manny. Thank you, Sankeet. I appreciate it. And so hopefully this gave you a flavor for some of the challenges and the new opportunities for TMSs, transportation management systems. Thanks, everyone.
Thank you.